You've seen the headlines, right? Companies exploding with growth, soaring to incredible success, and then suddenly, bam, they hit a wall.
Yeah, outages, firefighting, customers leaving.
Exactly. It's a tale as old as the digital age itself. The thrilling, maybe terrifying question is, what's the secret to not just growing, but, sustaining that growth without constantly putting out fires?
That's the million-dollar question.
Well, that, my friend, is the challenge of scalability. Today, we're taking a deep dive into The Art of Scalability by Marty Abbott and Michael Fisher. And let me tell you, this isn't just some dry technical manual.
No, not at all. It's really a comprehensive guide, building organizations, processes, technology architectures, the whole shebang, designed to handle immense growth.
And our mission here is to pull out the most critical insights, the stuff that can really help you navigate this incredibly complex landscape.
What's truly remarkable, I think, is that Abbott and Fisher aren't just, academics. These guys have serious real-world chops. Yeah. Their experience spans some of the biggest names out there. eBay, PayPal, Quigo, GE, Motorola. They've actually lived through these scaling nightmares.
So they've built that around-the-clock reliability they talk about.
Exactly. And they've packed this book with practical, battle-tested solutions, stuff that's surprisingly demystifying, actually. You're going to find some incredibly valuable perspectives here.
Absolutely. So, yeah, get ready for some genuinely surprising facts and maybe a few aha moments that'll fast-track you to being truly well-informed on this. It's crucial stuff. Let's unpack this. Okay, so when things start breaking, when scalability issues pop up, we often jump straight to, well, more servers.
Or better code, or maybe a shiny new database. That's the reflex.
But the authors, they really pull back the curtain on something profound here. They say scalability crises are almost never technology problems alone.
Never just tech. Think about that.
Why is that so hard for companies to grasp? I mean, what are they missing when they just assume it's a tech fix?
Well, it's an incredibly common blind spot, isn't it? The core insight, the real nugget here, is that while the symptoms, the outages, they look technical,
yeah,
the root causes almost always start way earlier.
Mm-hmm.
They start with organizations and people, and they spread to process, and only then do they really manifest in the technology.
So it's like a chain reaction.
Pretty much. It's a series of, well, human failures, as they put it, that cascades down. It leads to product failure, losing customers, and ultimately unhappy shareholders. We tend to focus on the outage, instead of tracing it back.
Back to the decisions, the structures, the habits that kind of created the tinder in the first place.
You got it. It's not the database itself just deciding to fail. It's the human decisions about the database, or maybe the human-driven processes around managing it, or the lack thereof.
Wow, okay, that's a huge shift in perspective. And the book aims to move companies from what they call a vicious cycle, constantly reacting, firefighting, to a virtuous cycle.
Right, by tackling people and process scalability first. It's about being proactive, not just, waiting for the next fire.
And this isn't just for, hotshot Silicon Valley startups.
Not at all. That's what's great.
Yeah.
The models, the approaches they discuss, they're remarkably industry agnostic. They've been proven successful in some of the fastest growing companies of our time.
So it applies everywhere. Front-end systems, back-end, business intelligence.
Yep. ERP, CRM systems.
Yeah.
You name it. Yeah. This is pretty universal wisdom for any organization that actually wants sustained growth, not just a flash in the pan.
Okay, building on that idea, let's dive deeper into that people aspect. Because the authors highlight this real paradox.
Mm-hmm.
People, organizational structure, management, leadership, they say this stuff is at the heart of everything you need to scale a company and a platform.
Right. Absolutely foundational.
Yet, they're the things we overlook most often. It's like obsessing over the fancy paint job when the foundation is crumbling.
It truly is. And, they bring up Sun Tzu, believe it or not.
The Art of War guy.
Really? Yeah. He provides this fantastic analogy. He explains that scaling a large organization is no wise different from fighting with a small one. It is merely a question of instituting signs and signals.
Signs and signals.
Exactly. And that applies directly to how your org structure impacts your ability to scale. Think about their fictional company, Allscale. Their HRM software grew super fast, and boom, they suddenly needed a scalable engineering team. Proper management and leadership became absolutely critical just to keep pace.
That makes so much sense. Clear communication, clear roles. clear signals.
Yeah.
But isn't there a fine line there between, helpful signs and signals and just too much bureaucracy, stuff that can actually slow down a fast-scaling company?
Oh, absolutely. That's a critical tension.
Yeah.
And the book helps you navigate that. They really unpack the distinction between leadership and management, which honestly I found incredibly insightful. Well, leadership, they say, is the pulling activity. It's about defining the big picture, the vision, the mission, those aggressive, measurable goals, SMART goals, specific, measurable, achievable, relevant, time-bound. It's about inspiration, direction.
Okay, the why and the where. And management then is the how. More about the execution, the practical nuts and bolts.
Precisely. Management is the pushing activity, plotting the actual path, driving the organization forward, hitting those specific objectives day to day. Both are absolutely critical. And honestly, it's pretty rare to find someone equally brilliant at both.
Yeah, I can see that.
What's also fascinating is their focus on the mission first, people always leader. It's not about ego, not about being the smartest person in the room.
It's about
being selfless. It's about having your direct reports want to follow you from job to job. That's the real measure. They share these anecdotes, like even seemingly small things, a leader abusing company perks, how that can just destroy credibility.
Oh.
And bam, there goes your ability to scale effectively because trust is gone. Trust is absolute currency in scaling.
I can absolutely see how quickly that erodes everything. They also touch on the Dunning-Kruger effect, right? That leaders sometimes overestimate their abilities because maybe they haven't had formal training.
Exactly. And that lack of self-awareness can lead to massive scalability blind spots. Because, if you don't know what you don't know, how can you possibly plan for it?
Right. You can't see the iceberg coming.
Pretty much.
Yeah.
And to tie everyone into that bigger picture, they talk about creating a causal roadmap to success.
What does that look like?
Well, for our fictional all-scale, imagine even their janitor understanding how a clean, organized office helps the engineering team focus, which speeds up feature development, which ultimately boosts shareholder value.
Wow. So it connects every single role, no matter how small it seems, to the overall mission. That's powerful.
It really is.
So if we're talking organizational design, they say there's rarely a single right or wrong structure. It's more an art and not really a science.
True. Each structure has its pros and cons.
So what are the key things you need to think about when you're trying to design a structure that actually scales? What matters most?
The key is really understanding how the design impacts things like individual productivity, right?
Yep.
How easily stakeholders can even understand the structure, the smooth flow of work, and crucially, the friction between teams.
Friction, like bottlenecks.
Exactly. A poorly designed structure creates silos, bottlenecks. It just chokes growth, while a really well thought out one can accelerate it massively.
And team size. This one surprised me. It's tempting, to just throw more people at a problem. More hands, faster work. Seems logical.
It does, but the authors reveal this kind of counterintuitive truth. Beyond a certain point, the average output per person actually drops as teams get too big.
Really? Why?
Think about it. The explosion of communication channels, right? The coordination overhead, just keeping everyone aligned becomes a nightmare. They give us clear warning signs for teams that are too large, like poor communication starting, morale degrading. Or, flip side, teams that are too small, which leads to disgruntled partners, maybe micromanaging because the manager is spread too thin.
Finding that Goldilocks zone.
Pretty much.
So, okay, we've got the right people, maybe the right leaders, optimized structures. But man, this all sounds like a lot of investment, time, money, effort. How do you actually make the business case for all this essential scalability work, especially to the execs holding the purse strings?
Yeah, that's often the biggest hurdle. They call it the experiential chasm.
You what?
The experiential chasm. It's basically the communication breakdown between the tech teams who live the pain and the business executives who maybe don't fully grasp the technical nuances.
They speak different languages.
Exactly. And it often leads to what they call destructive interference in discussions. To bridge that chasm, you absolutely have to quantify the impact in terms they understand. Dollars and cents.
Show them the money.
Precisely. They provide an all-scale HRM outage graph as a great example.
Yeah.
You can use it to accurately calculate the real cost of downtime. A 5-hour outage, for instance, might mean 18% missed traffic and revenue, even after you account for any pent-up demand spike when you come back online. That's real money walking out the door.
Wow, that visual makes it incredibly concrete. And it's not just the immediate lost sales either, is it? It feels like it goes deeper.
Oh, much deeper. Scalability failures also hammer your customer acquisition costs. Think about it. Potential new users hit your site, have a terrible first experience because it's slow or down.
And they never come back.
Gone forever. And then there are those significant intra-organizational costs. Your highly paid engineers spending days fighting fires instead of building valuable new features. Or your customer support teams getting completely swamped and burned out.
Right, all those hidden costs.
They're huge expenses that directly hit the bottom line, often unseen until, well, it's way too late.
Okay, moving on. Pillar number 2, process. Now, many of us, myself included sometimes, might hear the word process and immediately think.
Bureaucracy, red tape, slows everything down.
Exactly. But the art of scalability really flips that on its head. Processes, they argue, are actually a critical part of scaling an application.
Right, because they assist in management tasks and standardization and free employees up to focus on more creative endeavors. It's actually about enablement, not restriction.
Okay, enablement. I like that framing.
It's about finding the right amount of rigor, though. That's the key. You don't want zero process, but you don't want process for process's sake.
So how do you find that balance?
Well, they use models like the CMMI, that's a Capability Maturity Model Integrated Framework. It's basically a roadmap showing how mature and optimized your processes are. And it helps you explore different levels, from just sort of getting by what they call incomplete all the way up to truly optimizing everything. The goal isn't just having processes, it's having the right processes for your specific stage of growth. You want to avoid both under-engineering and over-engineering your operations.
Makes sense. So how do you know when you need to implement a new process or maybe fix an existing broken one? What are those clear warning signs you should look for?
Oh, there's some classic tells. A great indicator is when you see engineers doing the same basic task totally differently. Like bug fixes consistently going into the wrong code branch because there's no standard method.
Chaos.
Total chaos. Or if employees seem overly burdened by mundane stuff, right, leading to complaints, burnout, maybe rushed designs because they're constantly reinventing the same wheel over and over.
Yeah, okay. If you want to standardize behavior and free up that creative brain power, improving the process is critical.
Yeah, absolutely critical.
That's a clear signal. The book then walks us through managing the inevitable incidents, problems, and full-blown crises with some really practical frameworks. When an incident happens, they recommend the DRIER process.
DRIER. Let's break that down. Detect, report, investigate, escalate, resolve.
Right. And they use an all-scale example. A customer complaint about accessing HRM documents triggers this whole cycle. It really highlights how having a structured approach is essential for a fast, effective response.
And building on that, while they definitely take time and effort, they can feel costly in the moment. Postmortems are absolutely vital for learning.
The after-action review.
Exactly. This is where organizations truly mature. They teach you when to conduct them. Maybe not for every tiny little glitch, but definitely for those incidents that have hugely and negatively impacted you.
Right.
And they detail the 3 phases. Timeline, just the facts. Issue, what went wrong. And action, what are we going to do about it?
Yeah.
And crucially, this isn't about blame. It's about uncovering systemic issues to prevent it from happening again.
And man, nothing screams scalability crisis needing process like eBay back in 1999. I still remember those headlines. It was brutal.
Oh, yeah. The book describes how eBay suffered multiple major outages, including one that lasted over 20 hours.
20 hours. Unbelievable.
And it slashed its stock price from the mid-$20 down to like $10.42. That's a stark example of the monumental cost of not having these kinds of processes dialed in. It wasn't just a tech failure. It was fundamentally an organizational and process failure.
That crisis forced their hand, didn't it?
It was a profound turning point for them. It forced a huge organizational shift, brought in new leadership, and led directly to establishing crucial processes, things like scalability summits, operations meetings, incident management processes, change management processes, stuff they desperately needed.
It's a powerful reminder that crises, if you actually analyze them properly, can force positive change.
Definitely. And when things really hit the fan, like during that eBay outage, and you need to manage communication during the crisis, they highlight the importance of a war room, even if it's virtual now, and having something like an asynchronous chat or IRC channel.
Like a live text chat.
Yeah, basically a real-time log. It documents actions, decisions, ensures immediate command and control. And critically, they emphasize the importance of sincere customer apologies afterward. Apologies that actually take ownership, not those vague corporate non-apologies that just erode trust even further.
Taking ownership, yeah, that's crucial for rebuilding trust. And speaking of control, they have this line, unmanaged change will cause you significant problems.
Oh, absolutely. Every single touch, twiddle, prod, or poke, their words,
Uh-huh.
to hardware or software, that's a change. And it needs to be logged because every single one carries risk.
They use a great analogy for change management. It's like the FAA's air traffic control.
Right. It's not there to slow planes down. It's there to allow the velocity and quantity of change to increase while decreasing the number of change-related incidents.
It's about enabling speed safely. I like that.
Yep. And they outline the essential info for a good change log. Time, system affected, what the actual change was, what you expect the results to be, and who to contact if things go sideways. They illustrate this with an all-scale login failure scenario, showing how quickly you can track down the problem if you have a robust log. Saves hours, maybe days, of painful firefighting.
Okay, this next part. This really makes you think. The fast or right dilemma.
Ah, the classic trade-off.
Every business decision, especially in product development, faces this project triangle. Speed, quality, and cost. And the kicker is you can't maximize all three at the same time. You just can't. It's a fundamental trade-off we face constantly.
And the all-scale HRM billing feature they describe provides such a stark example. They prioritize speed above all else.
Yeah.
And it led to a crippling 38-hour processing crisis, just completely melted down. It perfectly illustrates the severe real-world consequences of not balancing those constraints thoughtfully.
So how do you make those calls?
Well, they explore different methods. From just relying on gut feel, which, let's be honest, is often unreliable, especially at scale, to using a more detailed decision matrix, weighing the pros and cons systematically.
Right.
And they ask this truly provocative question, a real gut check. Would you feel comfortable standing in front of your board explaining your decision?
Ooh, yeah. That forces you to think long-term, doesn't it? Consider the real impact beyond just shipping the feature fast. All right, let's get into the third pillar. Technology. This is where, let's face it, many people start when they think scalability.
It is, but as we've seen, it's really only one crucial piece of a much bigger puzzle.
So the authors give us guiding principles for building robust systems. They stress that architectural principles aren't just, vague ideals. They have to be smart, specific, measurable, attainable, realistic, timely.
Exactly. Like saying your goal is infinitely scalable, that's a nice ambition, maybe, but it's not a principle you can actually design by. It's too vague.
Gotcha. So what are some concrete examples they give?
What's incredibly practical are AKF's 12 architectural principles. They give you real guidelines. For example, N+1 design.
N+1.
Meaning you build redundancy in. Think. One for you, one for the customer, and one to fail. It's a powerful way to think about ensuring availability. You always have at least one spare.
Okay, I like that. Simple but effective.
Or another big one, scale out, not up. This prioritizes horizontal scaling, adding more smaller, cheaper machines rather than just buying one massive, faster, much more expensive server.
Right. Don't put all your eggs in one very extensive basket.
Pretty much.
That buy one non-core principle really stood out to me too. It directly challenges that not built here syndrome you see sometimes.
Oh yeah, the NIH phenomenon.
Right.
Where companies feel this compulsion to build absolutely everything themselves, even commodity stuff.
Right. And the principle says, if something isn't a core competitive differentiator for your business, just buy it off the shelf rather than building it from scratch.
Exactly. This avoids creating these incredibly costly, complex custom solutions that often, ironically, become the source of the company's scalability crisis down the road because nobody else knows how they work or how to maintain them.
Yeah.
They illustrate this with All Scale's dilemma. Should they build this proprietary interpreter called Scale Talk?
Yeah.
And the question is, does that really add unique value? Or is it just engineers wanting to build something cool?
It's about strategic focus, right?
Yeah.
Keep your best talent working on the stuff that truly makes you unique in the market.
You got it. And to make sure new designs actually follow these principles, they talk about processes like Joint Architecture Design, JAD, and having Architecture Review Board, an ARB.
Okay. How did those work?
The JAD team typically includes a software engineer, an architect, maybe an operations engineer. They are responsible for creating the actual design.
Okay.
While the ARB, which is usually a board of respected senior leaders and domain experts, they are accountable for approving designs, making sure they align with the company's established architectural principles.
Checks and balances.
Exactly. And AllScale's image storage feature provides a prime example. They didn't have this process, rushed to design, and it led to a super costly redesign and significant project delays later on.
Okay, here's where my mind started bending a bit. the AKF Scale Cube. This thing is brilliant. It's a visual tool to help you conceptualize how to split systems up for massive scale.
It really is powerful. The Scale Cube gives you 3 fundamental dimensions, 3 different ways to think about breaking down your system.
Okay, lay them out for me.
All right. First, the x-axis. That's basically horizontal duplication or cloning. Think of like a typing pool where you have multiple identical copies of your application running and a load balancer just spreads the work out among them. It's all about scaling out.
Got it. More identical workers.
Second, the y-axis. This is functional decomposition, splitting your system up by service or by function. For example, in an accounts receivable system, you might separate the invoicing service from the service that handles delinquent accounts. This creates specialized, smaller, independent pools of resources.
Okay, splitting by job function.
Yeah.
Makes sense.
And third, the z-axis. This is data decomposition or sharding. Splitting the data itself, usually based on the customer or the requester. You might use a lookup service or some deterministic algorithm, but essentially you're dividing your entire customer base into n different pods or segments, and each pod handles only its slice of the data.
Wow. Okay, XYZ. Duplication, function, data. So how does a company like Allscale actually use this cube in practice for a complex system like their CRM, HRM?
They'd likely combine the axes, so they might use z-axis splits first to create customer pods. Then within each pod, they'd use y-axis splits for different functional areas like a billing service versus a user profile service. And then for each of those specific functional services within a pod, they'd use x-axis scaling running multiple copies to handle the required transaction throughput.
Layering the splits.
Exactly. And for databases, it's a similar idea, but you have to think about things like replication delay concerns. But you can still use the axis. X-axis for read replicas maybe, Y-axis for functional sharding, like separating product catalog data from order data, and Z-axis for customer-based data partitioning.
Okay, that cube is a really powerful mental model. And beyond just splitting things up, you need to create fault-isolative architectures, right? The idea is to contain the blast radius if something goes wrong.
Absolutely critical. Think about segmenting an old Ethernet network. If one segment went bad, you didn't want it to take down the entire network. Same principle applies to your whole platform architecture.
How do they refer to these isolated segments?
They use terms like swim lanes, pods, or slivers. Basically, these describe components that are designed to be completely fault-isolated from each other. Allscale's CRM/HRM systems, for example, are designed with multi-tenancy and these customer-based z-axis splits running across multiple live data centers. That's a prime example of this approach.
And the benefits are?
Huge. Fault isolation boosts availability. One pod failing doesn't kill the whole service. It speeds up problem detection because the failure is contained. It can lower development costs because teams work on smaller independent units. And it enables that multi-dimensional scaling we just talked about with the cube. It's really about containing chaos.
So what does all this mean for how we design things, like synchronous versus asynchronous calls? It sounds like we should always be aiming for asynchronous if we want scale.
You're right to pick up on that. It's a major theme. What's often overlooked is that synchronous calls, where one system calls another and waits for a response if you overuse them, they can become massive bottlenecks.
How so?
Imagine a slow monitoring service call that holds up a user's web request. That user waits, maybe hits refresh. Now there are 2 requests waiting.
Yeah.
It can cascade and bring down the entire system.
The cascading failure.
Exactly. They even bring up the classic dining philosophers problem from computer science.
Oh yeah, the philosophers trying to eat spaghetti with shared forks.
That's the one. It perfectly illustrates how resource contention, multiple processes fighting for the same limited resources in a synchronous way, can lead to deadlock and complete unscalability. It's almost comical how often we inadvertently recreate that exact problem in our own distributed systems, isn't it?
Yeah, it really is.
So generally, stateless systems, ones that don't need to remember anything between requests, are much easier to scale using that x-axis cloning. If you must use state, like new session data, they explore solutions like trying to avoid it altogether, maybe centralizing it, using a dedicated caching service like memcached is a common pattern, or sometimes decentralizing it cleverly.
Okay, let's talk about data. Managing too much data. Storage is cheap, right? So just keep everything forever.
The common misconception. While raw storage costs are falling, data is absolutely not free. The authors are quick to point this out. They identify at least 6 costs of data that go way beyond just the disk drives.
6 costs? Like what?
People to manage it, software licenses, power consumption. Data centers use a lot of power.
Mhm.
Physical data center space, the capital expenditure on servers, networks, the processing power needed to actually use the data, and of course, backup and recovery infrastructure. It adds up incredibly quickly.
Wow, okay. That's a lot more than just the cost per gigabyte.
Which raises a really important question.
Hmm.
What's the actual value of all that data you're storing? They call it the cost-value dilemma. The reality is the value of most data decreases significantly over time, sometimes very quickly.
So that old data might cost more to keep than it's worth.
Exactly. Blindly retaining infinite data just because you can, maybe for some vague notion of strategic competitive differentiation, can actually dilute shareholder value because of all those hidden ongoing costs.
So what are the solutions? How do you manage it?
Well, things like implementing tiered storage moving older, less frequently accessed data to slower, cheaper storage tiers, transforming and summarizing raw data into more useful, smaller aggregates, and leveraging distributed processing frameworks. They mentioned Google's MapReduce as a classic example.
For MapReduce?
Yeah, it's a programming model that essentially lets you split massive data processing problems into many, many smaller, manageable chunks, the map step, and then combine the results, the reduce step. It allows you to process petabytes of data incredibly efficiently across large clusters of commodity hardware.
Very cool. Okay, and what about monitoring all these increasingly complex, distributed, scaled-out systems? We talked earlier about process for handling incidents, but what about the technology of monitoring itself? How do you actually see what's going on without drowning in alerts?
Great question. They argue that traditional bottom-up monitoring, just slapping agents on servers to watch CPU and memory, often fails. Why? Because the systems themselves often weren't designed with monitoring in mind from the start.
So you get tons of noisy alerts, but no real insight.
Pretty much. The world-class approach, they say, is top-down monitoring. Think of it in 3 steps.
Okay, step 1.
Step 1. Is there actually a problem? Start with the user experience. Are users seeing errors? Is performance slow? And look at real-time business metrics, revenue per minute, searches per second, shopping cart abandonment rates. Compare these against historical trends and forecasts. Is something off?
Okay, start with the business impact then.
Step 2, if yes, there is a problem, then ask where is the problem? Now you look at your systems level monitors, CPU, memory, network load, disk I/O, across your different tiers and services. Using that y-axis split knowledge, where are the anomalies?
Pinpointing the area. And finally,
Step 3, once you've localized the area, then you ask what specifically is the problem. This is where you drill down into monitors built directly into the application code, detailed error messages, specific service health checks, queue lengths, database query times. You build the monitoring capabilities and analyze the alerts in that crucial top-down order.
user, system, code. That makes a lot of sense. Lastly, let's touch on strategic data center planning. Seems like it's not just about finding a big room with good AC and power outlets anymore, especially at scale.
Absolutely not. For hyper-growth companies, power utilization, how many kilowatts you can draw, often becomes a key constraint long before you actually run out of physical floor space.
Power is the real bottleneck.
Often, yes.
Yeah.
And location considerations become critical. You need access to low-cost, high-quality, reliable power. You want low geographic risk. Places like Dallas, Atlanta, Phoenix, Denver are popular because they're less prone to major natural disasters compared to coastal areas. And sometimes, yeah, proximity to your key employee base matters for on-site support.
And then there's this rule of 3. What's that about?
Right. We already talked about N+1 design for servers, remembering 1 for you, 1 for the customer, and 1 to fail. Well, they extend that thinking to data centers. They make a fascinating case that having 3 geographically dispersed, live, active data centers can actually reduce overall costs compared to having 2, 1 primary, 1 backup DR.
3 is cheaper than 2. How does that work?
It seems counterintuitive, right? But 3 live sites offer true disaster prevention. You can lose one entirely and still operate at scale. It allows you to place data centers closer to different customer populations for lower latency, and it gives you multi-sourcing flexibility for things like network providers. When you factor in the reduced risk and operational flexibility, 3 often comes out ahead for truly large-scale, resilient operations. It's a really strategic way to think about infrastructure. Hashtag outro.
Wow. Okay, so this deep dive into the art of scalability, it's really shown us that true sustainable scalability is, well, it's a holistic endeavor, isn't it?
Absolutely. It's not about finding that one magic bullet, that one piece of tech. It's much more about the intricate dance between having the right people, clear and adaptable processes, and yes, a thoughtfully designed technology architecture.
All 3 legs of the stool need to be strong.
Exactly. And the real art of scalability, as the title suggests, seems to lie in understanding and actively managing the dynamic interactions between those three pillars, turning potential crises into opportunities for learning and sustained growth.
Yeah, it's a continuous journey, right? A
Yeah.
process of learning and adaptation, not just a one-time fix you implement and forget about.
Couldn't agree more.
The book's preface has this bold statement: a company can't operate in the digital age without flawless technical operations. But I think this deep dive has really revealed that flawless operations extend so much further than just the tech stack.
Way beyond. It encompasses everything we've talked about.
So maybe a final thought for you listening. How much are you truly investing in creating that genuinely flawless operational environment across all three of those pillars: your people, your processes, and your technology? Something to really chew on.